Part 1. Construct appropriate graphs or charts to compare the relative frequency and cumulative relative frequency in each dataset. We have to calculate what is the relative frequency and cumulative for both domestic and international dataset. Table 1 shown relative frequency for domestic passenger traffic of all airlines in the Asia-Pacific region. So this is the group data from the raw data given that consists 5 class intervals. It has been converted into a frequency distribution in the following table. Relative frequency is how often something happens divided by all outcomes. So how do we find relative frequency? For both domestic and international, is frequency divided by sample size, which is 24 in total. So from the table, we can calculate the relative frequency for each group passengers. Frequency 14 divided by sample size 24 equal to relative frequency, which is 0.58. And to know the percentage, multiply the relative frequency by 100%. Relative frequency for domestic travels are 0.58, 0.21, 0.13, 0.04, and still remain 0.04. Table 2 shown relative frequency for international passenger traffic of all airlines in the Asia-Pacific region. Relative frequency for international passenger travels are 0.88, 0.04, 0.04, 0, and 0.04. From the data, we can construct a bar chart that depicts the relative frequency. It is shown in chart 1, which is a bar chart of relative frequency for domestic travels. Overall, we can see a clear downward trend in the relative frequency for domestic travels. This same goes to the relative frequency for international travels, as you can see in chart 2. Table 3 shown cumulative relative frequency for domestic passenger traffic of all airlines in the Asia-Pacific region. A cumulative relative frequency distribution gives the proportion or fraction of values that fall below the upper limit of each class. Cumulative relative frequency for domestic passenger travels are 0.58, 0.80, 0.92, 0.96, and 1.00. Table 4 shown cumulative relative frequency for international passenger traffic of all airlines in the Asia-Pacific region. Cumulative relative frequency for domestic passenger travels are 0.88, 0.92, 0.96, 0.96, and 1.00. From the data, we could construct an OGIF. An OGIF is a visual representation of a cumulative relative frequency distribution. It is shown in graph 3 for cumulative relative frequency for domestic passenger travels. Overall, we can see the data grew strikingly from 0.58 up to 1.00. This is same goes to cumulative relative frequency for international travels, which can be seen in graph 4. The data also increased dramatically from 0.88 up to 1.00.
For the part 2, which is calculate and compare measure of central location in each dataset. A measure of location is a summarized list of numbers by a typical value. So there are 3 main measures of central location, which is mean, median, and mode. To calculate mean for domestic, which is 26,731,800 divided by 24. So the answer is 1,130,829 passengers. For international, which is 10,945,618 divided by 24, and we get is 456,068 passengers. To calculate median for domestic Pelita Air Service, which is 530,698 passengers, plus with Japan Airlines, which is 610,901, so the equal is 570,800 passengers. For international, Japan Asia Airways 88,100 plus Japan Airlines, so we get 88,668 passengers. The mode for domestic is 457,079 passengers, and the international is Asia Airline remains the mode, which is 4,713,336 passengers. So for the comparison is the mean number of domestic, which is 113,829 passengers, higher than international passengers that only 456,068 passengers. So for the median for domestic passengers is 570,800 passengers, that higher than international passengers median, which is 88,666 passengers.
In part 3, we will calculate percentiles and construct box plot in each dataset. We will be using this formula to calculate percentiles. For domestic, insert the total of airlines to n plus 1, which is 24 plus 1, and change p to 25. After that, calculate the numbers and we will get 6 when 25 as an answer. Then using the answer from the question above, take airlines number 6 and 7 in the domestic table and minus it. The answer will be 5367. After that, pick number 6 airlines in the table, which is 239635, and plus it with 0.25, then times it with 5367. We will get 240976.75 as an answer. Next, using the same formula, but for this one, change 25 to 75. Calculate the numbers and the answer will be 18.75. For this second part, replace P25 to P75 as the previous one. Pick airlines number 18 and 19 in the domestic table, then minus it. The answer will be 283882. After that, take 1415153 and plus it with 0.75, then times it with 283,882. The answer will be 1628064.5. As for international, insert the total of airlines to n plus 1, which is 24 plus 1, and change p to 25. After that, calculate the numbers and we will get 6.25 as an answer. Then, using the answer from the question above, take airlines number 6 and 7 in the international table and minus it. The answer will be 2187. After that, pick number 6 and 9 in the table, which is 72915, and plus it with 0.25, then times it with 2187. We will get 73461.75 as an answer. Next, using the same formula, but for this one, change 25 to 75. Calculate the numbers and the answer will be 18.75. For this second part, replace P25 to P75. As the previous one, pick airlines number 18 and 19 in the median table, then minus it. The answer will be 13533. After that, take 106584 and plus with 0.75, then times it with 13533. The answer we will get is 116733.75. Moving to box plot, the table instruction above are the mean Q1, Q2, Q3 and max for domestic and international airlines. As for domestic, the mean is 888.29, then Q1 is 240,976.75. For median, the answer will be 570.7993, and for Q3 is 1628064.3, while for max is 4570798. While box plot for international, the mean is 32362, then Q1 is 73461.75. For median, the answer is 88.67, and for Q3 is 116733.75, while for max is 471333.75.
Okay, I will explain how to answer the part 4, which is calculate and compare measure of the person in each dataset. So we need to find the 4 things, which is the range, mean absolute deviation, variance and standard deviation, and coefficient of variance. For first, we need to find the range for domestic and international. So to find the range, we need to calculate the maximum value minus the minimum value. So the range for domestic is 4481969, while for the international, the range is 4680974. So we can see from the international and domestic, the international more better than the domestics. Next, we need to calculate the mean absolute deviation. Formula for mean absolute deviation for domestic, we need to calculate the all sum of the each dataset minus by mean. So divide by n, which is the population. So negative 0.04 divided by 24, which is the population. The answer for the mean absolute deviation for domestic is negative 1.67. While for the international, we use the same formula for the mean absolute deviation. So we calculate the each dataset minus by mean, and then negative 0.08 divided by 24. The answer for mean absolute deviation for the international, negative 3.33. So we can see from the international and domestic is more better than international. We need to find the variance and standard deviation. So we need to find the variance for domestic. To find the variance for domestic, we need to calculate all sum of the each dataset and minus mean and power by 2 divided by n. So the variance for domestic is 5.57 and the standard deviation for domestic is 2.36. While for the international, we use the same formulas. Total all sum of the each dataset and minus by mean and power of 2. So the answer for variance for international is 2.1. So the standard deviation for international is 1.49. So we can see the domestic is better than international based on the variance and standard deviation. And next, we need to calculate the coefficient of variance. To find the coefficient of variance for domestic, we need to calculate the standard deviation and divide by mean. So we can see the answer for domestic is negative 1113 at 26.6, and then while for the international is the answer for the coefficient of standard deviation is negative 4,56065.93. So we can see from the domestic and international, the domestic is better than international. So that's all from me. Thank you.
For part 5, we need to calculate and compare measures of associations in each dataset. As you can see here, this is our table that we have done for all the information to calculate covariance and correlation coefficients. To find covariance, we need to divide the total of frequency minus by mean of each dataset, which is domestic and international. The answer will divide by 23 because n minus 1. We can know that n refer to the total of airline, which is 24. To find correlation coefficients, we need to find the standard deviation of x and y first. Okay, after that we can get the answer, which is standard deviation x is 1211496.768. Y is 1114200. After that, to find the value of correlation coefficients, we need to divide the covariance by the total of standard deviation of x and y. Okay, so the answer that we can get is 0.088292823 or 0.08.